Hi everyone, we're looking at number 17 on page 318. Draw a diagram illustrating the set of points x, y, z in three-dimensional space, where x is in between 0 and 1 inclusive, where y is in between 0 and 1 inclusive, and where z is in between 0 and 1 inclusive. So step 1 is to set a scale, and notice how they're in between 0 and 1 inclusive. So on the x, y, z axis, we're going to move or set up a scale up to 1. So here's the first step. If you look at the statement, x is in between 0 and 1 inclusive, that means I can start at 0, 0, 0, and I move towards 1, 0, 0. So I draw this line. And as I'm extending this, I also notice that y is in between 0 and 1 inclusive. So what that means is I move towards 0, 1, 0, and again I can draw a line. Now I can already tell because it's in between 0 and 1 inclusive, I can form a parallelogram. So the way to do this is to draw a line that looks like that, like that. There's the other point. If I look at this last part, z is in between 0 and 1 is inclusive. So I go up to 0, 1, 1, and again I connect this. Now, as I am beginning with the end in mind and reverse engineer, I can imagine this looks like a cube. And to draw this, you can start with the square at the back. There's also a square at the front, and the way you can draw this is by first connecting this line, just like that. Going across, back down, there's the square at the front, just like that. And to be very clear, let's label every single point. So I'll start with the most basic point, 0, 0, 0. There's the 1 on the x-axis, which is 1, 0, 0. There's the 1 on the y-axis, which is 0, 1, 0. There's the 1 on the z-axis, which would be 0, 0, 1. And if you continue, this corner is going to be 0, 1, 1. This other corner will be 1, 0, 1. The bottom corner is going to be 1, 1, 0. Last but not least, this corner is going to be 1, 1, and 1. So there's the diagram. I hope this makes sense.